Hello everyone. Today we're going to talk about the analysis section in your science fair project. So what is the analysis? The purpose of the analysis is to evaluate your raw data and look for trends in variability using statistics. The results and the analysis part go together under the same section when you write your paper. The analysis is incorporated into the results. You will use a computer program called Excel to analyze your data. The analysis is made up of three components. One, the descriptive statistics. This summarizes the characteristics of a data set, and you incorporate this into the data table and your graph or graphs. The inferential statistics compare the differences between the treatment group to help make generalizations about trends and variability in the larger population of subjects. And statistical significance is incorporated into the written synopsis as the description of the null hypothesis being rejected or not rejected. So let's look at each component in more detail, starting with the descriptive statistical analysis. This component will be added to your summary data table or tables and graph or graphs in the results section. It involves summarizing and evaluating the raw data. The key descriptive statistics include the mean, which is the arithmetic average, standard deviation, which is the amount of dispersion or variability shown in plus and minus sign, in the measurements of a particular variable. This can also be considered the spread above or below the mean. The error bars on a graph are plotted using the standard deviation that you calculated, and the error bars are the visual representation of the standard deviation. We're going to see in the next slide that when the error bars overlap, this suggests, and it's a suggestion but not definite, this suggests that there's no difference between the groups, and when the error bars do not overlap, this suggests a difference between groups. Again, why this is called descriptive. So how do you incorporate descriptive statistics into your paper? So here you see the arrows pointing to the mean. Here you see the arrows pointing to the standard deviation, and then your number of trials in an example data table. And in the graph, you see how the mean is plotted into a bar graph, and then you see how the standard deviation is plotted in the form of error bars. So notice that the error bars is a spread that rise above and below the mean. This is why you need positive and negative values. Now you notice that some error bars are really big. This means that you have wide variation, and sometimes your error bars are very small. That means that you don't have a lot of variation, meaning that probably your results all circled around your mean and you had good precision. You can also notice how some error bars overlap. So for example, here you see this error bar overlapping with this error bar here. This suggests that there's no difference between these two groups. Now sometimes error bars do not overlap. For example, this error bar does not overlap with this error bar, and that suggests that there is a difference between those two groups. All right, we're going to continue. Component 2 is the inferential statistical analysis. This component is used to mathematically look for trends and the degree of variability. Variability provides a measure of how accurately any individual score or sample represents the entire population. You need to collect as much data as possible so you can run statistical analysis on your data that is meaningful. This is why at least 10 trials are required, which helps to minimize the impact of outliers. Now, you're going to be using the program in your computer called Excel, and these tests will generate an Excel table, and your teacher may require that you copy and paste this table in your results section. The two most common basic statistical analysis tests look for differences between groups. The first one is a t-test. It's a two-sample test that compares two means, and or an ANOVA test, which is an analysis of variance that compares more than two means. You can use one or two tests when analyzing your data. Other less commonly used tests for science projects that might be more appropriate depending on the data that you collected are the tests below. You're going to have to see your teacher about these. So chi-square analysis might be required for categorical data. a correlation or Pearson correlation. These look at strength and direction of relationships, and a linear regression. These kind of tests look for cause and effect. There are some great tutorials on how to conduct these types of statistical analysis. What's the p-value in inferential statistics? Inferential statistical tests work by calculating a p-value, or a probability value, which describes how likely it is that your data would have occurred by random chance, meaning that the null hypothesis is true or was failed to be rejected. The p-value is calculated to determine the statistical significance of your results. So a p-value of 0.05 is equal to 95% certainty or confidence, and it is the standard number used in science for data analysis. So a p-value that is equal or less than 0.05 indicates that there was a significant difference between your groups, and therefore the IV is having an effect on the DV with at least 95% certainty. If the p-value is equal or less than 0.05, then your null hypothesis can be rejected. If a p-value is greater than 0.05, that means that you don't meet the 95% certainty or confidence interval required in science. So this indicates that there was not a significant difference between your groups, and therefore the IV is not having an effect on the DV. If the p-value is greater than 0.05, then your null hypothesis is not rejected, or you failed to reject it. Component 3 is the section where within the written synopsis you're going to state your statistical significance. So inferential statistics gives us a mathematical certainty, or the p-value, that will allow us to accept or reject the null hypothesis. A null hypothesis proposes that there is no significant difference between experimental groups, or between an experimental group and a control group. Statistical significance means that there is a significant difference between groups as a result of the variable applied to each group. The difference is a direct result of the variable and not due to random chance. If you fail to reject the null hypothesis, that indicates that there was no significant difference between the groups, and any differences between groups were probably due to random chance. And if the p-value is greater than 0.05, then your null hypothesis is accepted. A rejected null hypothesis indicates that there was a significant difference between the groups, and these differences between groups are not due to random chance, but rather the independent variable having an effect on the dependent variable. If the p-value is equal or less than 0.05, then your null hypothesis can be rejected. How are you going to incorporate your statistical significance into your results? So here is an example of a paragraph that you would include within your written synopsis, and this is the wording that you would have. For example, you might say, an ANOVA test was done to determine if a statistical significant difference existed among means for blank, blank, and blank groups. The calculated value was blank, which is either greater or less than the critical value. That means that the hypothesis cannot or can be rejected. You can do the same thing with the t-test, and you can use the wording there below. For further help, be sure you are enrolled in the Science Project Help Canvas course. Watch the video lessons on graphing data tables, adding error bars, doing statistical tests like ANOVA t-test, and those other tests that might pertain to the data that you were collecting. Reach out to a science fair mentor directly through their posted email, or ask a question on the discussion board for this deadline. Attend lunch lab and ask your questions, and remember that your teacher is available and knowledgeable and able to help you every day. Thank you.